Hey everybody. Today's math lesson, we're going to be looking at more division. This time we're going to take a look at what remainders mean and what to do with them. Sometimes you'll see a problem that has a remainder, and if you're just asked to enter the answer, the quotient and its remainder, then good enough, you're done. You just type in those numbers, R, whatever. But what does it really mean to have a remainder? That's in real life the question that we must learn to answer. And that depends. It depends on what it is you're working with and what it is you're dividing. So, just a quick example before we actually look at a word problem together. Let's say we're outside at recess and there's some students playing with cars. I'm thinking about picturing like Gabe and Liam. Maybe that's a truck. Yeah, sure, that's a truck. Good, that's good. That's awesome. And here is a little car. It looks like a hat. Okay. Nobody needs to know anything. Looks like a bird. Okay, so let's say that Gabe and Liam have 5 little cars. And I know. Don't tell Mrs. Ballum. My cars. Now they're starting to look like turtles. And then there's a green one too. There's a green. We'll make the green one into another truck. So I think my trucks are the best. Okay, so we have 5. And Gabe and Liam really want to be fair. They want to make sure that they're playing with the same number of trucks. So, we can probably just use mental math and say, well, Miss Nelson, just give Gabe 2 and give Liam 2. And put the other one in your pocket. So if the question were, how many cars can they each have? The answer would be 2. Gabe gets 2, Liam gets 2. But if the question is Gabe and Liam each get the same number of cars and there are 5, what does Miss Nelson do and how many does she put in her pocket? The answer would be 1. So it would depend on what you're being asked, okay? All right, so let's just pretend this never happened. And move on to the next slide. So 4th graders don't typically like to reread, but I will say that when you have to figure out what a remainder means, you do have to be a little extra thoughtful. There are several different ways to interpret remainders, and today we're going to focus on one of them. Here's a problem for you. You can help me with this. Mrs. Steenberg bakes 39 cupcakes, 1 for each student in 4th grade. How nice. A container holds 5 cupcakes. How many containers will Mrs. Steenberg need if she wants to bring all 39 cupcakes to school? Okay, so this is a standard division problem. I'm going to go with yellow. And we have to divide 39 by 5. Okay, so the first thing I'm going to do, I'm not even going to worry about the fact that I'm interpreting remainders today. I'm just going to divide the way I've been dividing. And I'm going to see that 5 goes into 3 no times. You cannot put a group of 5 into 3. So we are going to move over and look at 39. 5 goes into 39. Well, I know that 5 can go into 39 7 times without going over. And if we went 8, it would go over. So 7 times 5 is 35. And that is going to be my mice step. So we divided and I multiplied. And now I will subtract, and I'm going to get 4. I don't need to bring anything down because I'm finished. I have nothing left to divide, and my remainder is smaller than my divisor. So the answer is 7 remainder 4. But this does not help me. 7 remainder 4 is sort of meaningless when the question is, how many containers does Mrs. Steenberg need? This answer will not help her. What this means is that she can fill 7 containers, but she's going to have 4 cupcakes sitting on her counter. And that's 4 fourth graders with no cupcake. So, in order to do this problem and to interpret this remainder, we need to round up so that everyone gets a cupcake. Instead of 7 containers of cupcakes, she needs to bring 8. So, going back to this problem one more time, I know that we only have 39 cupcakes. However, we need to think of the problem 5 times 8, which is 40, because 5 times 7 is too small. So if I only have 7 containers, 7 was my quotient, right? Then I'm going to have 7R 4. I'm going to have 7 full containers and then 4 cupcakes left over. I have to add another container to put these 4 into. So I've got 7 full containers, and then I have a container that does not get filled completely, but that's okay. I will have 5 in each of these 7 containers, and then I'm going to have 1 container with just 4. But those 4 students are going to be pretty happy that she brought them all in, okay? So today you're going to look at some more examples of problems just like this one,